Some compressors actually don't allow you to adjust the threshold. They're called fixed threshold compressors. This is an example of one. Gives you the attack, the release, the input and the output, but no threshold. It gives you a ratio choice of 4 to 1, 8 to 1, 12 to 1, and 20 to 1. But it doesn't allow you to pick what threshold you're going to be at, because this is set up that at zero level, meaning that the meter's at zero before it goes into the red, that's where the threshold is set automatically. These were initially built so that you didn't overload your gear. So it doesn't allow you to change the threshold at all. But the way you set these up, if you've got a plug-in that looks like this, it's called an 1176, one of my favorite compressors of all time. What you do is on the right side here, it'll allow you to choose +4. You press that button and it'll show you the input signal on the meter. When you adjust the input level so that the meter's jumping a little above and into the red, then you know that you're going to start compressing when it gets into the red. And then you hit the top button called GR, which is gain reduction, and it will show you the needle pulling back every time it goes over the threshold. It'll show you how much you're reducing the gain. So you adjust the input first to get the correct amount into the compressor so it's actually compressing over the threshold. Then you can adjust the attack and the release and the output level. And the ratio adjusts how much it's actually compressing. So that's a fixed threshold compressor. Here's a fixed ratio compressor. Fixed ratio compressor is something like an LA2A. People love the sound of LA2As. It's an optical compressor. The peak reduction control is the input gain to the detector circuit. The gain is the output control only as it does not affect the compression. So you've got a gain control and you've got a peak reduction. So the more you twist the knob on the right, the more it compresses. It's a fixed threshold as well. So it really adjusts the ratio when you have more peak reduction. This is actually a tube compressor, and it uses an optical device to do the compression. And that brings me to the fact that there's different kinds of compressor designs. If we're all on the same page that everything that's compressed sounds better, it stands to reason that different types of electronic designs, they'd all sound a little different. And so naturally you'd want to use certain types on certain sound elements. Here's the basic 5 kinds of compressor designs. The variable mu, that's meant to be a mu, not a u, is a good example of that is a Fairchild 660. Fairchild 660 in the compression world is like the Porsche. It is what everybody wants but can't afford. I saw one sell at auction actually recently for $47,000. They're one of the first compressors ever designed, and it's a tube compressor, and it's like 4, 5, 6 rack spaces, and it's heavy. It's got transformers and all that. It's a serious compressor, and it does sound really, really amazing. It sounds really good. It's a very soft knee compressor, and it's a tube compressor. The LA2A, on the other hand, the Tektronix LA2A, which we just saw a picture of, is an optical compressor. An optical compressor is a little different than the other designs in that the way that it operates is that it has a little light bulb inside that glows brighter with more input signal and glows less with less input signal. And there's a photocell that picks up how bright the bulb glows and adjusts how much signal comes out based upon that. Instead of it being a strictly mathematical calculation of, well, we're this much over the threshold, so the output needs to be less, it works on the intensity of a light bulb. Now, you know when you have a dimmer control on your light, it's not exactly linear, and it's sort of based upon how bright the filament glows in an incandescent light bulb. Every light bulb's a little different. And it's a physical device of how much electricity is going to make that filament glow more. It's a very kind of human kind of sounding compressor because it's based upon a physical property of a filament glowing brighter and brighter or less bright. So it's not a mathematical calculation on the part of a circuit. Now the FET type compressor, which is a design, is the URI 1176. Now as a typical great sounding FET type compressor, and that is 1176 is what I showed you before, And believe it or not, the whole architecture of the electronics is a Fairchild 660, but a solid state version. That's one of my very favorite compressors of all time. And the 1176 is actually one of those compressors that has been used on so many lead vocalists that you've heard through the years on records and recordings. The LA-2A is the same in terms of its use. It's been used on vocalists through the years on so many major recordings. The VCA type compressor, which is the DBX 160, is sort of the flagship of that kind of technology. It was built in the 70s and DBX made their name on it. A voltage controlled amplifier, that's what VCA stands for. The last one is the diode bridge type compressor, which is a Neve 2264 is sort of a famous version of. One thing that I may not have made totally clear is that all compressors have an input and an output. And it also has a third spot where you can actually control how much the amplifier either amplifies or reduces volume. In that first slide that I went through, it's either connected to the input or the output. The one thing I didn't mention, which I probably should have, is that third control lead, which controls how much volume comes out of the amplifier, can be independent of the input and the output, and can be controlled by a different signal entirely. That's where you get really unique effects. One thing that I did want to explain is that when the ratio of a compressor gets to be about 10:1, that's where it turns into a limiter. Limiter meaning that it's very severe and any signal above a certain threshold is not going to get much louder at all. It's going to stay at the same volume that it's at. It's meant to act as a brick wall where it won't allow signals to go past a certain level, never allowing the output to get past, like, say, a distortion level. You really brick wall limit how loud the signal gets.